Solving equations involving compositions. Example 1 says find all real numbers that satisfy the equation cosine 2x equals 1. So what I need to do is find out what is x. And I notice 2 times x is attached. I need to pull it out front. In order to do that, that means I need to take the inverse of cosine. Over here, I know what cosine of 1 is. That means the inverse here is also going to be 0. All right. So now I know what S is. S is going to be the cosine inverse of 1, which is equal to 0. So when I do that, I go back to my identities for cosine and I determine if S is less than or S is greater than 0. In this case, it's equal to 0. Then that means we're limited. And we're going to look for the set builder of x when it's equal to s plus 2k pi. And this, knowing that k is any integer, is going to give me all real numbers that satisfies this equation. So now let's come over here and let's do that. So I got 2x is equal to, because right now we haven't done anything with the 2. And I'm using this identity here, is equal to s, which is 0 plus 2k pi. Let's clean it up just a little bit. And I need x by itself, so it means I'm going to divide by the 2. So because it's multiplied to x, we divide. So now I got 2 divides 2 leaves me with 1. 1 times x is x. 2 divided by 2 is 1, leaves me with k pi. This is what's going to satisfy that equation. Let's go to example 3. Example 3 says find all real numbers that satisfy this given equation right here. Well, I notice I got a lot going on here. So the very first thing I'm going to do is I'm going to subtract the square root of 2 from both sides. So that gives me 2 sine of x half equals negative square root of 2. And I need to divide by that 2 because I need it off. I need the cosine, or excuse me, the coefficient on sine to be positive 1, and it's a 2, so let's divide by it. So now I got sine of x halves is equal to negative square root of 2. And let's pull this out front. And in order to do that, we have to take the inverse of sine. And when I take the inverse of sine, I get inverse of sine negative square root of 2 halves. And we know that's going to give me a negative pi force. So what I know is S is actually the sine inverse of that negative square root of 2 halves, which is a negative pi force. We know that that means S is less than 0. So my identity I want to use as a set builder of x that is equal to S plus 2 pi plus 2k pi, or we're going to use, so we have 2 sides here. So we're going to find a large number and a small number. So what I'm going to do is, now that I know what S is, I know that it's negative 4 pi. We just can't forget that we have this x halves, so we're going to have to do some extra work here. I'm going to take that negative 4 pi. And we're going to, let's not forget to add the 2 pi. That's 2k pi. I might just clean this up before I do anything to the x over here. So now just double check on our calculator. I got a negative 4 pi plus 2 pi, because those are the like terms, we can put those two together. Gives me a 7 pi force plus 2k pi. All right, so now what's going to happen is I got to undo this here and decide here and get x by itself. And since it's divided, that means I'm going to multiply all sides by that 2. Okay, so now I got x is equal to 14 pi fourths plus 4 pi, okay, 4k pi. I noticed this reduces 14 pi, it reduces by 2. Right, 2 goes into 14 7 times, 2 goes into 4 2 times, and now I have x is equal to 7 pi halves plus 4k pi. Now I'm going to solve the other side. So I got x halves is equal to pi minus the negative 4 pi, or pi fourths, plus the 2k pi. And let's go ahead and put that together. So that means negative times negative is adding, becomes a positive. So we're going to add those two together. So this gives me x is equal to 2, or x halves is equal to 5 pi fourths plus 2k pi. And we're going to multiply all sides by the 2 because we want to undo that fraction. So now I got x is equal to 10 pi fourths plus 4k pi. So these are going to give me what satisfies the, it's going to give me everything that satisfies the equation. Just remember that when we come back to this, we notice that we get, we also had here, I just want to point out, we have a 5 pi fourths here as a small number. So I know that I got x is 5 pi fourths plus 4k pi. We got that as a smallest possible. We also got this as a large possible. And we also got this as an even larger possible. Okay, so, and then just plug in any number for k, and that's going to give us our real numbers. All right, so let's do number 3. It says and note we want to get the equations. So, okay, we want to get the equations to where we have sine of x is equal to a, and we can determine what it is. And in this case here, we got x is equal to half, or x half, right? Let me change this color. I like these colors, but I'm kind of getting distracted by it. All right. So what I'm going to do is I'm going to have to get x out to itself. So I need to add this one to both sides. So now I got 2 sine x half is equal to 1. And I need to divide by the 2 because I need the coefficient on sine to be a positive 1, and it's a 2. So now I got sine of x half is equal to half. And we need this out front, so I'm going to have to take the inverse of sine. And when I do that, I find out what is sine inverse of a half. We know that sine inverse of a half is s. That's what's going to be our s. We see that a here, in this case here, this is a, we showed it here. So a is a half. So what is sine inverse of a half? And that's going to give me pi 6. We know that s is greater than 0, so that tells me the identity I want to use. It's a set that builds on x. That is s plus 2k pi. Or we get x is equal to pi s minus s plus 2k pi. All right. So now that I know that, I'm going to use this formula, and I got a little messy there. So it's kind of hard to read. Let me rewrite that. This side here. Just write it down underneath it. That way it's not so messy. It's pi minus that. pi minus the s plus the 2k. All right, that's easier to read. So now that we've done that, we're going to say, okay, well, when we want to find the smallest, we know that we can say, oh, okay, well, and this might help you with the previous one, x over 2, or we can say we'll define the very smallest, and we know that s, in this case here, is pi 6 plus the 2k pi. Okay, that's just define the very smallest one. So when I do that, I need to multiply both sides by 2 because I need x by itself. So now I have x is equal to, well, the 2 and 6 reduces, right? And that gives me pi thirds plus 4k pi. So this is going to give me my smallest, a very, very smallest one. Now we're going to move on, though, to solve what our identities have. So we have x is equal to pi 6 plus, oh, we got that one over there already. Let's do the next one. And x equals the pi minus the pi 6 plus 2k pi. And don't forget, this x was over 2. So we're going to have to do that step again. But before I do it, I want to go ahead and clean up what I can. And I notice I got pi minus 6 pi, or pi 6. So let's go ahead and do that. Pi minus that pi 6, and that gives me 5 pi 6 plus 2k pi. And now we're going to multiply by 2. So now I got x is equal to, well, the 2 and 6 reduces, 5 pi thirds plus 4k pi. And now we have the information we need to find all real numbers that satisfy that given equation. Okay, number 4, find values of x in the interval of 0 degrees to 360 degrees that satisfy the equation given to us here. Well, we're going to do the same thing here. We're going to get that x by itself. So I need to subtract the 1 from both sides. I see that I have a coefficient of 2 here. So I need to divide by 2. I notice that I still have sign involved with the x. So I need to take its inverse in order to get x by itself. Now that I've done that, I know s is equal to my sign inverse of a negative half. Well, what is a negative half? Well, we are talking about degrees, so make sure and change the mode on your calculator to make sure that you're in radians. Some of you may have shift to go to it, just depends on what your calculator is. So I'm going to take my sign inverse of the negative half. I keep wanting to throw that negative out front. And gives me a negative 30 degrees. All right, so I know this. What this tells me is I need to find the points around it. Because it's negative here, we're going to have to find, we'll take that 180 degrees and we're going to subtract that 30 degrees, which gives me 210 degrees. And then we're going to take that 360 degrees and subtract that 30 degrees. And that gives me 330 degrees. So that tells me what we're working with. And now when I want to find the equation that satisfies it, I'm going to take that 2x. And I'm going to put s plus the k of 360 degrees. I'm going to do 2x equals s plus k of 360 degrees. And we're just going to plug in these two that we found. All right, so now we're going to finish up by solving for x. We're going to divide 2 on both sides, right? When we solve by 2 on both sides, now I get x is equal to 105 degrees plus k of 180 degrees. X is equal to 165 degrees plus k of 180 degrees. And now let's actually find the values. So let's let k equals 0. When I plug in k equals 0 here, I get x is equal to 105 degrees, right? So let's plug in k equals 0 here. Well, what happens? We get x is equal to 165 degrees. So we got 2 values. Let's find the other ones. Let's let k equal 1. Well, when I do that, get x equals 105 plus 1 times that 180 degrees, which gives me that 285 degrees. And let's let k equal 1 here. All right, so I'm going to plug in 1 for k. I get 165 degrees plus 180 degrees, which is 345 degrees. Now I got a set of values that are real numbers for this equation. I got 105 degrees, I got 165 degrees, 285 degrees, 345 degrees. Okay, guys, so just depends on how many answers they want. If you continuously go on, you can let k equal 2 and so on. So let's solve for number 5. Number 5 says find the values of alpha in interval of 0 degrees, 360 degrees that satisfy the given equation. All right, so what I know is that cosecant. Cosecant is going to be 1 over sine, right? So therefore, I know that my sine of x is equal to 1 over cosecant, right? And you can put x since I use x there. And in this case here, what I'm going to do is say, okay, now I have sine of x is equal to 1 over cosecant 3 alpha equals 2. And when I do that, I see that my sine of x is equal to 1/2, right? Because we have that over 1. And now I'm going to plug in for my x, this 3 alpha. Okay. Now, the next thing we need to do is determine, we'll find the inverse because we need to get alpha by itself. And now that I've done that, I see that 1/2 is, or sine inverse of -1, or excuse me, sine inverse of 1/2 is going to be 30 degrees. So therefore, we know that s is greater than 0. So we're going to use the identity of the set that builds on x is equal to s plus k of 360 degrees. And we're going to also have x equals 180 degrees minus the s plus k of 360 degrees. That's just be because s, in this case here, is equal to 30 degrees. And it's greater than 0. So we're using this identity. Well, what is s? Well, we know it's 30 degrees. And okay, this side we got a little bit more work to do. Let's clean it up. All right, so now we know the equations. Now we just need to finish up and realize, okay, I've been plugging in X here because that's what the identity. Well, what is X? X is this 3 alpha. All right, so now we need the coefficient on alpha to be 1, and it's a 3, so let's divide by 3. So now I got alpha is equal to 10 degrees plus K of 200 or 120 degrees. And then I have alpha is equal to 50 degrees plus K of 120 degrees. And now let's find the real numbers. So we're going to plug in when K is equal to 0. Well, we know that alpha is 10 degrees. K is equal to 0 over here. Alpha is 50 degrees. K is equal to 1. We get alpha is equal to 130 degrees. When K is equal to 1, we get alpha is equal to 170 degrees. And guys, if you need to, plug it in. That means that's 50 degrees plus K, which is 1, times that 120 degrees, which gives me 50 degrees plus that 120 degrees, which equals 170 degrees. So if you need to actually physically write it down, I encourage it. Let's go one more step. Let's find when K is equal to 2. And I'm going to go ahead and put it in here. Just sometimes it's not as obvious. And that is a degree sign. All right, so now I got 10 degrees plus 2 times that 120, which gives me 240, and then we add it, and it gives me 250. Over here, we're going to let K equals 2, and alpha is equal to 50 degrees plus 2 times 120 degrees. Gives me 50 degrees plus 240 degrees, which is 290 degrees. So now we got some real values. We got 10 degrees. We got 50 degrees. We got 130 degrees. We got 170 degrees. We got 250 degrees. And we got 290 degrees. And those are some real values. Okay. There's one, so just, take your time, don't get in a hurry. Just find, the values that it gives you. I do have one more I would like to work out for you. And let's go. Well, we got 2 more. I was thinking I had 1 more. We got 2 more. Let's do 2 more. So this one here says find all values of beta in interval of 0 degrees to 360 that satisfy the equation. Use degrees, and we got cotangent. So what I'm going to do is get the beta out front, right, by taking the inverse of cotangent. Okay, let's get my eraser working. So when I do the inverse of cotangent, inverse of 1, I notice that cotangent, we know is going to be 1 over tangent, right? Which we also know is 1 over sine divided by cosine, which gives me back cosine over sine. We know all this. All right. So now what I need to do is look at when tangent, when this here is going to actually give me an answer of 1 for cotangent. Well, I know, just knowing that if I was to go to the unit circle, I can get the order pair of square root of 2 halves, square root of 2 halves. So this is cosine sine. So I know that if I take the square root of 2 divided by 2, all divided by square root of 2 divided by 2, we end up with this notation. And I'm just writing it to show you how I came up with cotangent of 1. So now that when I do this, we know that we're going to keep change flip. So I got square root of 2 divided by 2 times 2 divided by square root of 2, which gives me my 1. And that's what we want. So we're going to pick this order pair, which gives me a degrees of 45. Okay, so knowing that, I'm going to come back over here and I'm going to say beta thirds is equal to cotangent inverse of 1, which is equal to 45 degrees. All right, so now I know what S is. S is cotangent, or excuse me, S is 45 degrees because it's that cotangent inverse of 1. Okay, moving on. I know based upon that and the identity from cotangent that I'm going to use, I get beta thirds is equal to my S plus K of 180 degrees. So now I'm just going to plug in for S. All right. Now beta is divided by 3, and beta only needs to be a coefficient of positive 1. And so what I need to do is undo this fraction by multiplication, because fraction multiplication undoes division. So let's multiply by 3. So now I get beta of 45 times 3 is 135 degrees plus K of 504 degrees. And now we got our equation. And just plug in for K and we'll find all real numbers. So let's do our last one. All right, our last one is on radians. So make sure your calculator is converted to radians. And we're going to find all real numbers on the interval of 0 to 2 pi that satisfy the following. And I notice I have a lot going on. So before I can take the inverse, let's add this square root of 3 to both sides. So now I got 2 cosine, 2x is equal to square root of 3. Coefficient of cosine is 2. It needs to be a positive 1, so let's divide by 2. Now let's get x by itself. So we're going to take the inverse of cosine. Now I know what S is, right? And when you go to get to the unit circle, or you plug it in, and then make sure and change our to radians right quick. I'm taking the inverse of square root of 3 divided by 2. It gives me pi 6. All right, so now I know what my S is, right? And we're going to go to the identity to find it. So now let's take our identity, and we have to be sure and do the 2x because we have to factor that out in just a little bit. Plug in for my S. And I need to get x by itself with the coefficient of 1. So let's multiply by, oh, excuse me, we are multiplying. So in order to undo multiplication, we need to divide. Kind of got used to the multiplication there for a little bit. Let's divide by 2. So when I do that, now I got x is equal to, and if you need to, let's just rewrite this one here. We got to keep change flip. So what happens is we keep the first, change to multiplication, flip this one. And what do I get? I get x is equal to pi 12s plus 2 divides 2 is 1. So now I got this. Okay, so y'all see that? So that was one side of it. or one value of it. We also know on the unit circle, if you go look, we also get another value at this, and it's going to be 11 pi 6. So let's find it. Okay. Okay, again, we need to divide by 2. So now I get x is equal to 11 pi 12 plus k pi. Now that I know this, we got our equations. And we just plug in for k. So if I let k equal 0, then I know I get pi 12s. If I let k equal 0 here, I know that I get 11 pi 12s. If I plug in k equals 1, then I get x is equal to pi 12s pi, or plus pi, right? And when we add those together, well, let's do some basic math right quick. When I add those together, I have to have a common denominator. And if you notice, pi is over 1. We just don't write the 1 there. Well, the common denominator in this case is 12. So now I got pi all over 12 pi plus 12 pi, which is 13 pi 12s. So we've got these two values, and we got this value, and now let's find the other one. So when I plug in k equals 1 over here, I get 11 pi 12s plus the pi, and we'll do it the same way. And now we get like 23 pi 12s. So we know our values, and you just keep going on. It just depends on how many values they would like to have answers for.